All right, hello to everybody in my Algebra 2A classes. I hope that you are healthy and that everybody in your family is healthy. I hope this video finds you well. I'm going to start with one fairly simple topic that we haven't covered yet in rational expressions, and that is multiplying and dividing. So first we'll see how multiplying and dividing works in regular fractions. You can see here I've got two fractions multiplied. I've also got two fractions divided. And then we'll see how it works in rational expressions. You can see here I have two rational expressions being multiplied together. And then here I have two rational expressions being divided. So, starting with multiplying fractions. The general rule is that we would just multiply straight across. So if you wanted to just jump into this right away, you could do 1 times 6 over 3 times 7. That would give you 6 over 21. And then you could look for common factors. In this case, you could write 6 as 3 times 2, and you could write 21 as 3 times 7. So this would simplify to 2 over 7. But sometimes it's easier to recognize these common factors before we multiply across, because we can see that this 3 that we found is already here in the original problem. So instead of multiplying 3 times 7 together and then splitting it back apart, what you can do instead is just think about each fraction by itself and look for any matches between the tops of these and the bottoms of these. So in this case, I'm going to keep the 1/3 written right here. I'm going to write the 6 as 2 times 3 over 7. And then I can see right away that I can cancel the 3's and just get 2/7 again, a little bit easier. It's not wrong to do it this way, to multiply straight across. But when we have the opportunity, it's nice to look for some matches between our two fractions that might jump out at us more easily than when the numbers are multiplied and they're a little bit bigger. Okay, so that is multiplying fractions. Now let's talk about dividing fractions. This might seem like something totally different, but because of the way that fractions work, multiplying and dividing are almost the same. When we divide, we just have to write one extra step. And sometimes people summarize this step as keep, change, flip. This refers to keeping the first fraction, changing the division sign into a multiplication, and flipping the second fraction. So I could write the same problem as 3/5 times 4 over 3. Now, once again, I'm going to look for matches. And I can see right away that I have a 3 on the top and a 3 on the bottom. We could not cancel if this was just multiplying and we had 2 3's on the top, they would not cancel. We can only cancel something on the top with something on the bottom. It doesn't matter which side it's on though. So I have a 3 and a 3 that I can cancel right away. And I can see that the answer is 4 over 5. Or if you wanted to find this as a decimal, it would be 0.8. Now, we could multiply across the same way that we kind of started off over here. You could multiply 3 times 4 to get 12, and 5 times 3 to get 15, and then go through that same process of looking for matches, but we kind of would be doing some extra steps here because we already have a match before we even multiply. Whatever's left, if there's something that is left over after you have a match, you would still multiply that. Just like we did the 1 times 2 here, once we got rid of the 3 that was a matching part of the 6. So multiplying, look for any matches, and then multiply across. Dividing, first you need to keep, change, flip, and then look for matches and multiply across. Just like we've been doing with other things with rational expressions, we're going to look at some rules about factors that match and factors that don't match. So when we look at this rational expression, we want to think about the top and the bottom of each fraction as being pieces multiplied together. Sometimes there's only one piece, and sometimes there are multiple pieces. Whenever I have an addition or a subtraction in the fraction, that should set off warning bells for you that you can't find any matches or cancel anything out until these addition and subtraction signs are contained in some parentheses. In this case, you could look for matches between x and 2, but these are both pretty simple terms and it's easy to see that they don't have any match. And there's no other type of factoring that will help me do anything with this either, so I'm just going to put parentheses around the whole thing. If you have just an x term and just a number term, then your solution to containing your pluses and minuses is just to put parentheses around the whole thing. Now if I wanted to, I could write 5x as 5 times x, and I could change this x cubed into 3 x's multiplied together. Now I can see that the only match that I have is an x here with an x here. I will cancel those. And then what I have left over is x plus 2 times x over 5 times x minus 2. If I hadn't contained these factors, I might be tempted to try to either cancel the x's here or the 2's, but these are not an exact match, so I'm just going to keep them both. Now the last step is just going to be to rearrange this into sort of the normal order, so we'll put this x squared in front of the factor in parentheses, and I'll just write the bottom as 5 x minus 2. If you feel comfortable with this, you can skip this middle step and just look at this, realize that it's going to be x squared times x plus 2, and write the top like that. I could do an additional step here of distributing, and I'll show you what that looks like. But to start off with on this topic, you can just stop here. So I could multiply my x squared times x. That would give me x cubed. X squared times 2 would be 2x squared. And then on the bottom, this would become 5x minus 10. You usually don't want to do this type of step where you're distributing until you're completely done with everything else. So, for example, I wouldn't want to do that step before I was looking for factors to cancel. So that's an example of multiplying two rational expressions together to get one rational expression. It's really not too bad. It's a lot easier than adding and subtracting, which I've seen you guys do pretty well with, so I have confidence that you'll be able to do it. Now let's see what we do to divide two rational expressions. This is going to be the same relationship as it was with fractions. It's going to be the same process, except that first we will keep, change, flip. So let me start with that. Keep, change, flip. That's going to be x squared minus y squared over x plus 3 times, that's the change, and then my flip is going to be 4x over x plus y. Okay. Now this bottom term here, there's no factoring method that I can use to write this as two pieces multiplied together. So I'm just going to contain that plus sign in parentheses. This top term, even though I only have two terms, I could just write parentheses around it and then I would not find any matches. But what I'm going to do instead is recognize that these are two perfect squares. I can write x squared as x times x, and I can write y squared as y times y. So when I rewrite this fraction, I'm going to write it as x times x makes x squared, y times y makes y squared, and then one of these gets a plus and one gets a minus. This works just the same as if it was x squared minus 9. We would do 3 and 3 because 3 times 3 is 9. If it's x squared minus y squared, we do y and y because y times y is y squared. This x plus 3 on the bottom, I'm just going to contain that addition in some parentheses times 4x over x plus y. Now, because I did this factoring step, we can recognize that I do actually have a match here that can cancel out. So now I'm going to write the answer as 4x times x minus y. That's multiplying these two tops together and just writing it in the normal order. Divided by, on the bottom, the only thing that's left is this x plus 3. If it's the only thing there, it's okay to keep it without parentheses, but it wouldn't be wrong to write them. Okay, and then if I was going to do the last distributing step, I would get 4x squared minus 4xy over x plus 3. But if it just says divide and it doesn't say simplest form, for now, you can leave it like this. You don't need to do this distributing. But we will do that soon. All right, thanks for tuning in. I hope it was helpful. There's several ways to contact me listed on the Canvas introduction module if you're having any trouble or if you have any questions. And I'll talk to you again soon.